Hey chemistry students and chemistry enthusiasts. Today we're doing another type of titration. This time we're going to be titrating an unknown solution of sulfuric acid, H2SO4, with a known concentration of sodium hydroxide. We'll also be graphing the pH so that you can all see what happens to the pH of something as you titrate it. Right? Okay. So in this reaction today, this is the base that we're using. We know its concentration with high precision. This is the sulfuric acid that we're going to be using. We know its concentration is approximately 0.75 moles per liter, but we're going to confirm that or find it with better precision. Now, what makes this reaction a little bit more complicated than a simple titration is that sulfuric acid looks like this, and its formula is H2SO4. So sulfuric acid has two hydrogens that it loses, whereas in simple titrations, the acid will only have one hydrogen that it loses. So when we react sulfuric acid with sodium hydroxide, which is NaOH, each hydroxide can only accept one hydrogen from an acid. And so the sulfuric acid still has one hydrogen to lose, and that means that it can't just react with one sodium hydroxide, but there need to be two present to accept both hydrogens of the sulfuric acid. And they react to produce two water molecules instead of just one, and one sodium sulfate. To clean this up a little bit and put it on one line, and so this would read that 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide to produce 2 moles of water that are liquid and 1 mole of sodium sulfate. And so the titration equation that we used before, that the molarity of the acid times the volume of acid used equals the molarity of the base times the volume of the base used, is oversimplified. And it's not really the molarity of the acid and the molarity of the base, but it's the molarity of the hydrogen ions and the molarity of the hydroxide ions. So if we go back to how we derived this before, that it's the actual moles of hydrogen have to be equal to the moles of hydroxide. We introduce a new concept, a new variable, where instead of just the concentration of the acid, it's actually the concentration of hydrogen ions. And that is actually called the normality. So this is the normality of the acid, and it represents the concentration of the acid times how many hydrogens are in it. So the normality of the acid is the molarity of it times the number of hydrogens it loses. Conversely, the normality of the base because it's all about hydroxide, would be the molarity of the base times the number of hydroxides it loses. So on the bottle of the sulfuric acid we were testing, it said that it was approximately 0.75 molar for its concentration. And if we want to think about how that relates to the normality, it has 2 hydrogens that it loses. And so it's approximately 1.5 normal sulfuric acid. It also means that when we are solving for, what we solve for in the titration equation is actually the normality of the acid. And so to calculate its molarity, we would be dividing by 2. The bottle of the sodium hydroxide that was used had its listed molarity as 0.5253 molar. But since sodium hydroxide only has 1 hydroxide, in this case, the molarity is the same as the normality. So we're going to start off this experiment by conditioning the 2 burettes. This one will have the base and this one will have the acid. Again, conditioning makes sure that no matter what was in these before, that it's kind of all flushed out. So now with each of these conditioned and filled with the sodium hydroxide and the sulfuric acid, I'm going to, I filled them up past the 0 mark, and I'm going to very carefully drop some of these, each that the level, their starting level is going to be at the 0 mark, into a waste beaker.
What is a waste beaker?
This is a beaker, and this just means that it's where I'm gonna put the stuff I'm just going to pour out.
Waste beaker?
Yep.
Means just pour out?
Yep.
You just want to pour a little bit.
Because I was just getting it to the first line.
Oh. What is that blue?
That's a pH probe. Alright, so now we've got the base burette and the acid burette at 0 to start off. I'm going to pour out the waste beaker and bring in a fresh beaker. I've put in a magnetic stir bar to help us out. I'm going to start off by putting in some distilled water because the pH probe that we're using today needs to be submerged to work correctly. And then I'll be putting in about 10 milliliters of acid, put in some indicator, we'll use phenolphthalein today, and then put in sodium hydroxide until it changes color. So this is the base burette. You can see the meniscus is right on the 0 line, the bottom of the meniscus. This is the acid burette, also right at the 0 line. I've put in some water into the beaker to start off, and I'm going to put between 10 and 12 milliliters of the sulfuric acid. Okay, so now I've put in some acid.
Yes, put it in some.
This is where it ends up. So approximately 10.8, maybe 10.81, 10.80 milliliters of acid. And the pH probe is giving a reading of 3.13, 3.14. I'm going to collect my first point, and the milliliters of sodium hydroxide added, I'm going to say that that is 0. I've not added any sodium hydroxide yet.
Cool.
Next, I'll be adding a few drops of phenolphthalein.
Oh, that is cool.
It stays clear, which would it be expected since it is acidic.
Ooh, yeah, that is cool.
Now I'm going to position the base.
That is cool. And you are going to base the products. Are you going to put the products or no?
Now it's time to drop the base. Are you ready for the base drop? Okay. So I'm going to add sodium hydroxide until the pH changes by 0.1, and then I'll keep the next point. So now the pH is increased to 3.23 or 3.24, so I'm going to keep that point. And looking at the burette, there have been 9.65 milliliters added. I'm going to drop the base again until the pH changes. Now here we are at a pH of 3.41. The volume of base that has been added at this point is 14.90 milliliters. I'm going to drop in more base. Here we're at a pH of 3.52, and now the volume of base added, 17.70 milliliters. You see how it's turning pink when the drops hit it? Look, when the drops hit the water, it turns pink a little bit. Is that cool? I will, I have to type something. So now we're at a pH of 3.6, and the volume of base added is 19.79 milliliters. The pH is now at 3.72, and the milliliters of base added, 22.35. We're now at a pH of 3.83, and it's been 24.48 milliliters. We've now got a pH of 3.96, and the volume of base added is 26.52 milliliters. We're now at a pH of 4.12, and the milliliters of base added is 28.70 milliliters. We've now got a pH of 4.33, and the volume of base added is 30.70 milliliters. We're now at a pH of 4.50, and milliliters of base added is 31.80 milliliters. We're now at a pH of 4.91, and milliliters of base added is 33.55. The slope is increasing, so I have to be very careful to add base slowly at this point. Right, so we're now at a pH of 5.86 and a volume of sodium hydroxide added of 34.68 milliliters.
Why did you put that one right there?
Well, because now it's making it turn pink a lot more. No, please do not. I'll tell you when you can do it, okay? So now we're at a pH of 6.24. I only added a couple of drops of base, so we're only at 34.78 milliliters. And then it disappeared.
How did it turn pink and it disappear?
Well, because it mixed more. So once it turns pink and stays pink, then that means that we're done. So again, just a couple of drops added, and the pH, no, please do not. The pH is changing drastically now. We'll let that adjust. The volume, please do not, no. The volume of base added right now is 34.95 milliliters. We're going to add just one drop at a time now, very sensitive to pH changes.
Staying pink now.
Hold on, we'll see. All right, so the solution, because of the phenolphthalein, is turned light pink, which means that its pH is, right around 10. The pH probe is still catching up a little bit. You can see it's still increasing. So before taking our next point, we'll let that stop moving. And notice the slope of the curve, the graph, when it changed color.
See, it's staying pink.
The volume of base added once this turned pink and stayed pink, is 35.02 milliliters. And we're just going to add a couple more drops at a time to see what happens past this peak, if it's going to keep shooting up further or if it's going to level off. You can see the deep pink in the solution shows that it's past the transition range of phenolphthalein. Nope. Please stop. I will tell you when you can do it. Almost, okay? 35.62 milliliters. So at this point, adding more base is not changing the pH drastically. We're at 35.45 milliliters. Right now we're at 35.80 milliliters. Now we're at 36.40 milliliters.
What is on your computer you are doing?
That's showing this is going to. And now we're at 37.22 milliliters. Now we're at 39.51 milliliters. Right now we're all the way at 41.50 milliliters. Now we're at 42.90. And now we're at 45.60. You can see it's barely changing the pH at all at this point as we add more base. Okay, do one more until it gets about here. And we're going to end our graph today at 49.20 milliliters. To analyze the data, you're going to get the 3 pieces of data from the experiment. In the experiment, we measured out a volume of acid, we measured out a volume of base needed to neutralize it, and the normality of the base was known with high precision. And so you're going to put these into the real titration equation. We'll rearrange this to solve for the normality of the acid, what we're looking for. And we get that for our normality of the acid, it would be 1.703 normal. Now this is not our final answer because the normality of this acid, sulfuric acid, is not the same as its molarity since it has 2 hydrogens. Normality and molarity are the same only if an acid has only 1 hydrogen to lose. And so this needs to be divided by 2 to get the molarity of the acid. We get for a final answer that the molarity of the acid was 0.8517 molar. The bottle was listed as 0.75 molar, and so this is within reason, knowing how those things are measured and created, but definitely not quite the 0.75 that it was listed. Thanks for watching today, everybody. Hopefully this has helped you learn a little bit more about titrations, acids and bases, the difference between normality and molarity, and titration curves.
Bye-bye, Donna.